Hey there, and welcome. Today we're going to pull back the curtain on something we all use every single day, but maybe don't think too much about file compression. Making zip files, shrinking images so they'll actually send. It feels like a bit of digital magic, right? Well, by the end of this, you'll know exactly how the trick works.
I mean, we've all been there. You've got this super important report or a whole folder of vacation photos. You drag it into an email, you hit send, and bam, attachment too large. It is one of the most common frustrations in the digital world. And that exact moment, that's precisely why compression exists.
So, how in the world do you make a file smaller without just deleting parts of it? Well, the secret isn't actually magic at all. It's all about finding something that's hiding in plain sight in almost every single file you have: redundancy. Now, that's just a fancy word for information that gets repeated over and over and over again.
To really get what I'm talking about, let's use an example that has absolutely nothing to do with computers. Take this really famous quote from John F. Kennedy. Now, at first glance, it's 17 words long, but if you look a little closer, you'll start seeing some familiar faces pop up.
And once you actually break it down like this, the repetition just jumps right out at you. Ask is there twice, what is there twice, your country, you get the idea. In fact, pretty much half of this entire quote is just repeated information. And that right there, that's the gold mine that compression algorithms are looking for. Okay, so we found all this repeated stuff. Now what? Well, one of the simplest compression tricks in the book is to create a little dictionary for ourselves. The idea is, instead of writing out the same word every single time it appears, we just write it once in our dictionary and then point back to it with a simple number. So our dictionary would look something like this. Super simple. We just list out each of those repeated words one time and give it a number. Ask is now 1, what is 2, your is 3, and you can see the rest. This little list becomes our secret key, our code book for shrinking the sentence. And voila, here's what you get. The original quote turns into this mix of unique words and numbers. It's way shorter, right? And the best part is, as long as you have that dictionary, you can rebuild the original sentence perfectly with 0 errors. It's a simple idea, but it's incredibly powerful. But here's the twist, and it's a big one. What we just did, that's a very human way of solving the problem. A computer couldn't care less about words or spaces or punctuation. It sees only one thing: repeating patterns of data. And the way it finds those patterns is a whole lot smarter than just looking for duplicate words. So let's get into the real magic, the way computers actually do this. Most of the compression programs you use, like Zip, use something called an adaptive dictionary-based algorithm. Whoa, that's a mouthful. But the keyword there is adaptive. It means the program is building its own dictionary as it goes, and it's constantly changing it, adapting it to find the absolute most efficient patterns to save space. Just look at how much smarter a computer's dictionary is. It doesn't just see the word can, then do, then for, then you. No, it sees the whole phrase can do for you as one big, repeatable pattern. Or instead of your country, it just stores "ra country." It's always on the hunt for the biggest possible chunk it can replace to get the maximum savings. And the end result is a much, much more compact message. With this smarter, pattern-based dictionary, our sentence shrinks down to an even shorter, more efficient string of code. You can see it's way better than our first attempt. And here it is, the bottom line. The original quote took up, let's say, 79 units of space. Using the computer's smarter, pattern-finding method, we got it down to just 59. That's a real, measurable saving. Now just imagine that same principle applied to a massive, gigabyte-sized video file. Now, it's really important to know that everything we've talked about so far falls under one umbrella, called lossless compression. But that's not the only game in town. There are actually 2 major flavors of compression, and you use them both all the time, probably without even realizing it. So on one hand, you've got lossless. Think of zip files. It meticulously finds all the redundancy but guarantees you can get every single bit of the original file back perfectly. This is absolutely critical for things like text documents or computer code. Then you have lossy compression. This is what's used for photos, music, and videos. It makes files way smaller by cleverly throwing away tiny bits of data our eyes and ears probably won't even miss. But here's the catch. That data is gone forever. This brings us to a super common question. Does compressing a file ruin its quality? And the answer is, well, it depends on the type. If you're making a zip file of your term paper, the answer is a hard no. That's lossless, and your document will be restored perfectly. But if you're saving a photo as a JPEG or compressing a video, then yes, it does reduce the quality. That's literally how it works. It's the trade-off you make for getting that much smaller file size.
Okay, so the theory is great, but how about we make this practical? You can do this right now. You don't need any special software. The tools to create your own compressed files are already built right into your computer. Let's do a super quick walkthrough of how to make a standard zip file.
It really is this simple. You just highlight whatever you want to shrink down, you right-click on it, and if you're on Windows, you go to Send To, and then Compressed Folder. If you're on a Mac, it's even easier. The option is just called Compress. A few seconds later, you'll have a shiny new, much smaller zip file all ready to go.
So after all that, if there's one thing you take away from this, let it be this. Compression is not some random shrinking process. It is a very clever, very logical system for finding and removing redundancy, all that repeated information to save us a huge amount of digital space and, of course, a lot of time.
And that kind of leaves us with a big final thought. Every single day, we are creating an unbelievable amount of new data. We're talking everything from 8K video to giant scientific data sets. The need to make all of that information smaller and easier to manage isn't going away. It's getting more critical. So it makes you wonder, what's next? What's going to be the next big breakthrough in the quiet, essential magic of compression?